We really wanted to focus on creating the best possible system that could really match the rest of Eagle Technology. Eagle Technology right now is seen as the benchmark for drivetrain performance. And so we wanted to make sure that we elevated our game on cranks like we have with everything else in our drivetrain. As you can see behind me here, this is our San Luis Obispo facility. So we took that same systems engineering philosophy that we have in Schweinfurt with the product management team, working with the engineering team, and implemented that here with all this crew right here to come up with a new Dub platform. You know, there was 3 key factors that we really wanted to focus on: simplicity, durability, and compatibility.
Today what we have is 4 different frame standards that bottom brackets adapt to: BSA threaded English, press fit, diameter 41, BB30 42, and press fit 30, diameter 46. And with that comes a whole landscape of different spindle sizes, different bearings, some mounted external, some mounted internal, and all of those come with trade-offs. So the idea that we had for Dub is if we have one solution that can solve all of these frame standards, then we can put our time and engineering into optimizing that one solution.
Now we have consistent bottom bracket placement, so we know exactly where the loads are going, where they're coming in, and where they're exiting the crank arm. And that allows us to really optimize for a lightweight solution that's consistent across every single crankset platform.
Simplicity and durability are kind of tied together in that other competitors out there have gone this route as well. They have an oversized 30mm spindle that you put into all those frame shell standards as well. The difference that we looked at is that it's kind of a shortcut to get there. We didn't want to take that shortcut because our engineers back here felt that it's not going to provide a durable system. It didn't provide the sealing, the wear characteristics that we wanted from the bottom bracket, and so we took and started at 30mm and slowly kind of whittled it down until the engineers found that optimal range of, okay, we still get the benefits of the oversized spindle to get weight and stiffness, but then we now get the durability that you can't get with a 30mm system in some of those BB configurations that those manufacturers have.
The test lab is a pretty symbiotic relationship with actual riding. You know, we want to make sure that the tests that we're doing are somewhat correlated to what we're doing outside on the field. You know, we don't want to test something that's, you know, never going to happen out there because that's just not valuable to us. We're never going to be able to replace actually good quality feedback from somebody getting the part on a bike, going out and testing it and saying, yes, it's good or no, it's not good. But what we can do here is control the environment. We can pinpoint, we can turn those knobs and dials to really fine tune what we want to do and actually get an answer of what the part's doing.
So this test here is our bearing wet test. So it's basically simulating a wet condition out in the trail, like Pacific Northwest riding. Instead of having a sample out in the field where I would be riding it for like a year, we can run this test in a week and get a similar result so we can match it up to what we're seeing in the field. Then we can pull it apart at certain intervals, and basically we can catch when we're getting water into the bottom bracket.
So another part that's really critical to designing and the development process is test riding as well. So we really want to verify that what we're seeing in the lab is actually providing value for the customer out on the trail.
We ride the heck out of these, and some people have hundreds of hours or potentially even 1,000 hours on their crankset. We really love riding our parts.
That's kind of how it started, you know. Let's simplify our product line there and put all of the best features into it that we can. We weren't able to do that with the old, you know, dual platform scenario where you had some features in one of the platforms, some other features in the other one, and now you've got, you know, the sealing, the bearing performance, the lightweight, you know, the stiff spindle, all that all together in the Dub. No compromise regardless of what bottom bracket platform your frame runs. You know, compatible with all the stuff that's out there and has been out there for years now. So it solves a lot of problems.
From a compatibility standpoint, everything here that we have is backwards compatible, forwards compatible. It'll fit into all those frame shell standards that you have. So as long as you're buying a full Dove system, you'll be able to put it on your bike, whether you have an existing bike today or you're looking to get something here in the future. There's a lot of proliferation of standards right now, and we wanted to make sure that whatever we come out with isn't a new standard. It can be put into everything, because ultimately at the end of the day, we want anybody to be able to go out there and put SRAM product on their bike. In a nutshell, the Dove platform has the benefits of our 24mm systems from the durability standpoint, but yet the lightweight and stiffness benefits of our 30mm system all wrapped up into one single solution.